Factorising quadratics. So traditionally a quadratic is some x squared, some x's and a number. So x squared, some x's and a number. But it can also just as easily be written inside brackets. Hopefully from yesterday you remember how to expand these brackets. I'll do it for you now with letters A and B. It's x times x squared, x times b, which is plus bx, a times x plus ax, and then a times b. We'll call that ab. Simplifying, okay, you got a double-headed animal there. There's no other double-headed animals, however these x's can be collected. There's a plus b x's, and the number on the end is just a times b. You can see that these factors, if you like, add up together to give the coefficient of x and multiply together to give the number. Let me give you another example using numbers. Okay, expanding x plus 2 multiplied by x plus 6. Do it quickly. X squared plus 2x plus 6x plus 12. Okay, 2 times 6 gives 8x okay. Notice that the numbers 6 times 2 is 12 and 6 plus 2 is 8. That is always true for a quadratic. So using that new information, we should therefore be able to factorize. Now, factorize just means what?
Break into its factors.
Kind of. Break into its factors, but it really means put into brackets. So, sticking with my A's and my B's, I need an A and a B, but A times B must give 15 and A plus B must give 8. Okay, so I was going to start with my factors of 15. In fact, I'm just going to write down all the factors of 15 in a line. 1, 3, 5, and 15. 1 and 15, sure, they multiply together to give 15, but they don't add together to give 8. 3 times 5, they multiply together to give 15, and they add together to give 8. And because these are both positive, so will my answer. So, sticking with my rule, it's x plus 3, x plus 5. Okay, and That's what we call a fully factorized quadratic. Another example could be x squared minus 6x minus 40. Again, the a times the b must give 40. Hold on, it must give minus 40. Don't forget the minus here. And the a plus b must give negative 6. Again, write out the factors of 40 blindly off to the side somewhere. 1 is always 1. 2 if it's an even number. 4, 5, 8, 10, and 20, and 40. Again, all of these, well, 2 times 20 gives 40, but do they give a difference of 6? No, they don't. So it's not 2 and 20. 5 times 8 is 40. Do 5 and 8 give a difference of negative 6 or 6? No, they don't. If you look at 4 times 10, they give a multiplication of 40, and they also give a difference of 6. So it happens to be 4 and 10. Now I have to think about, well, given that I want a negative, I should put the negative next to the biggest number, so it's plus 4 minus 8. Sorry, I should have crossed that out. Minus 10. Plus 4 minus 10 gives minus 6. And remember, to get a negative product, it's you want a positive and a negative number. So I'm going to say A is plus 4 and B is minus 10. Answer x plus 4, x minus 10. I could equally write it this way. This is fine as well. Okay. And we've got another problem here. Again, we're looking for A and B, so that A times B gives minus 23, and A plus B should give minus 22 from here and from here. Factors of 23, 1 and 23. It must be these two. They also happen to give a difference of 22. So it looks like we're on the right track. One of them is minus and one of them is positive, because here you need a negative times a positive to get a negative. So only one of them is negative. This gives it away. I want to make the 1 positive, so that I wind up with 22, minus 22. If I made the 1 negative, I would wind up with positive 22, which I don't want. I want negative 22. Answer, x minus 23, x plus 1. This problem here can be a little bit off-putting, given that there's not a 1 in front of the x squared. the first thing you can do is see if the 4, if 4 goes into 8 and 4 goes into 60, because you can save yourself quite a bit of effort if 4 goes into 8 and 4 goes into 60. So I've chosen one that it does. Okay, 4 times 2 gives minus 8, or 4 times minus 2 gives minus 8, and minus 15. 15 fours are 60. So always a clever step. See if each of the terms is divisible by the same number and take that number outside the bracket like I have. Then we're going to factorize this, looking for, remember, a times b has to equal minus 15 and a plus b has to equal minus 2. Factors of 15, 1, 3, 5, 15. The pair, you get good at this with practice, the pair with a difference of 2 is 3 and 5. And I want a negative 15, so one of them has to be negative, not both of them, just one of them. And the difference, we want a difference of negative 2, so we need to put the negative next to the biggest number. So negative 5 positive 3. Okay, exactly the same practice. A times b must give positive 24. A plus b must give negative 11. Factors of 24. 1, 2.
3.
Thank you. 4, 6, 8, 12. Go through them one at a time, looking for the 2 that give a difference of 11. 1 and 24 doesn't work. 2 and 12, close but no cigar. 3 and 8 have a difference of 11. 3 and 8. Notice that the resultant is negative, or when you're adding, the answer is negative, and when you're multiplying, the answer 3 and 8 has to be a positive, which means they are both negative, because negative times a negative is a positive, and negative plus a negative, you get even more negative. So answer x minus 3, x minus 8.